And welcome everybody to the Daily Space Weather Show. This is the past 24 hours of the closest star in ionized helium. Some large plasma filaments which could get named, especially if you follow the hashtag #NameThatFilament on Twitter. Here we've added 193 angstroms, 60-minute running difference imagery to show some aspects of the extended corona. Some filamentary motions happening up there in the northern hemisphere. And one large prominent filaments here. One large prominent filament here in the southeast. South of those new sunspots. Again, if you want to name filaments after your friends, your foes, or even yourself, follow the hashtag #NameThatFilament over on Twitter. Sunspot number has risen since yesterday. Let's take a brief look. There is the SDO continuum. So some sunspot growth happening there in those central groups, now moving into the western sector. Besides that, mostly stable. Colorized magnetograms next. So unless something drastically changes, sunspot number should level out somewhat tomorrow. By the way, if you enjoy the content, don't forget to press the like button. Press share. Tell your friends and foes. Leave us a comment. Thanks to everybody who has. Thanks to our new YouTube subscribers. If you haven't seen the shorts, check them out. Of course, our channel does indeed cover the world's most comprehensive daily space weather content. So yeah, there you go. A lot of rather popular videos in our shorts section. You can find that in our Smash Lights playlist, actually. And don't forget to visit the links below the video, support the channel, continue to promote its existence. Solar flare kicking off as we make the video. We'll get to it. First, we're going to talk volcanoes. Volcanoes are next. And here's the list from volcanodiscovery.com. What do we got? Well, a list of exploding volcanoes. One of my bucket list volcanoes is Popocatépetl, which is producing an 18,000-foot plume of volcanic ash. Purache in Colombia now back on the list as well. Sudden increase of carbon dioxide and sulfur dioxide emissions, it looks like. Sabancaya also producing a 22,000-foot ash plume. Sabancaya, 24,000-foot ash plume. Next, earthquakes. That's what's happened in the past 90 days. It's been pretty quiet for the past 24 hours. These are the 5 and greater magnitude quakes. First one of the day was a 5.0 in the West Pacific, near Guam. That 5.0 was at 6:58 Universal Time this morning. And then about an hour and a half later, a 5.2 at Bolivia. That one was at depth, by the way, over 140 kilometers. Then Japan had a 5.0 at 12:38 Universal Time this afternoon. And some quakes here deep in the southern portion, well, deep in the Southern Ocean, really. The Baleine Islands, a 5.7 and a 5.5, and then finally this evening a 5.3 near Tonga. So that's what's been erupting as far as quakes. And here are some more videos for you. Another 24-hour SDO video, 171 angstroms. Now we've added 211 angstroms. That's the 211 angstroms running difference imagery of 60 minutes, by the way. Show additional depth. And here is that solar prominence in the southeast. Yeah, that one could definitely use a name. And let's talk stats. The 10.7 centimeter radial flux now up to 176? 176, I think it is. There is the 1 year graph of the radial flux represented by the black line. Another increase in the radial flux. No real surprise there. 167. I apologize. 167 is the new radial flux number. There you go. It'll go up 7 points, 8 points, something like that. 167. Space Weather Enthusiast dashboard. NOAA not forecasting any geomagnetic storms or unrest. Now we are seeing some activity here in the solar wind. Here are the past 4 hours. And we're seeing a rather fast wind with some significant solar wind density as well, showing up at the Discover. We'll get to it here momentarily. Again, that's the last 4 hours, the Earth's magnetic moment from space. A little uptick there in the solar wind parameters in the past couple of hours. Next, Earth's magnetic moment from the ground. Our ground magnetic perturbations map. That's what's going on at ground level. KP index still only at 0.67 is the average of global geomagnetism. Global geomagnetism at 0.67. And here comes some solar wind data. So check it out. The ACE very diffuse here and very slow, very slow. Speed barely over 300 kilometers a second and only about 2 protons per cubic centimeter. Now check out the Discover, which is also at Lagrange 1. Varying between nearly 30 protons per cubic centimeter at about 390 kilometers a second and about 4 protons per cubic centimeter and about 470 kilometers per second. So 2 different regimes there showing up, both much faster and both much more dense than at the ACE. So these are the variations you're seeing in the geospace magnetosphere movies. Looks like a mixed bag there. Coronal hole high-speed stream along with some CME impact features. So CMEs and high-speed winds there coming in at the same time, showing us those 2 clearly separate signals. Very nice. There are our GOES magnetometers, and it doesn't look like it's going to breed any kind of a geomagnetic storm, just a fleeting little variation in the solar wind there. And here's our top view ecliptic plane field plot. Now, we thought that yesterday we would be, as far as planet Earth, in a South Pole-oriented current sheet. But not yet. So that could still be days off, folks, as it looks like some indecision, once again, magnetically speaking, is happening east of Earth. So we could see it arrive in as little as about 6 to 10 hours, or it could hold off for an extended period of time. We've said it regularly on the channel. The magnetic environment can change with basically no warning. So there you can see a great example of indecision. Here you'll see the B field jumping all around. That's the blue portion. If you look over on the left side, that would be the east, the portion of the heliosphere to Earth's east. So magnetic indecision happening over there. Which pole do you think will win, north or south? Let us know in the comments. Next, our line of sight coronal hole plot. And we've got north and south pole magnetism trying to switch places over there in the east. So if you look up here, you will see the south pole magnetism winning up in this area. Down here, you'll see the north pole magnetism winning, and that is the sector boundary crossing trying to get decided. We're watching it play out on the channel. That's the past 4 days. And here comes the SDO imagery. There you go. So yeah, let us know in the comments when you think the sector boundary crossing will arrive, or which pole you think will win, as we could see an extended period of North Pole magnetism, or will the South Pole magnetic sector be here by tomorrow's daily space weather video? Let us know what you think in the comments. We're always interested in your theories. Next, sunspot number now up to just under 170, folks. Like 169, 168. I think 169 is the sunspot number at the moment. There you go. Sunspot number rising once again. Likelihood of large solar flares is there. There are multiple magnetically complex sunspot groups, and it looks like some that haven't gotten named yet. So we've got a few new sunspot groups here. Let's see. This one here should get a name by tomorrow, and this one here for sure. So that'll be, let's see, that'll be 3542, and then this one will be 3543, I suspect. And let's look at sunspots from the SDO continuum. There you go. That is what approximately 170 sunspots looks like. And let's take a look at this center disk portion a little bit closer up, because it contains a lot of ombre. So some evolution happening there of various sunspots, a great close-up view of what's happening. Remember, folks, you don't need to see a large sunspot to see large solar flares. It's all about the magnetic field shear. And let's move on to things like solar proton events. So that's still subsiding here. And let's show there's the 7-day, here's the 3-day graph, and the polar radial blackouts have subsided. We did have a nearly M-class flare happening as we did the show prep. That was a C8.8, a C8.78 class flare happened while we did show prep today. Let's take a look at flares from the SDO's perspective here. There you go. That's SDO 94 angstrom, 60-minute running difference along with 131 angstroms. And it looks like the TMAS, or most active sunspot, remains those center Earth-facing sunspot groups. So the group to the northwest is also pretty interesting. Basically what I mean is this is the most likely place to see a large solar flare between today and tomorrow. So multiple magnetically complex regions in there. And let's take a look at a star chart. That's what's going on overhead Lehigh Valley. It's skyandtelescope.org's star chart, a couple of gas giants up there. And here is our solar system forecast. Things today, things in 1 week. We'll have a crescent waxing moon by the 14th. And the astronomy photo of the day is the Cat's Eye Nebula. Yes, the Cat's Eye Nebula. Very nice. That's composite imagery featuring Chandra X-ray spectra as well as the Hubble Space Telescope optical imagery. So you can see this is somewhat symmetrical as you see these likely polar jet regions opposite each other, and then these dense, nebulous, gaseous regions in here, gassy, dusty regions. The Cat's Eye Nebula, quite famous. apod.nasa.gov if you want to check it out yourself. Next, CMEs. And what do we got? Things pretty quiet here. Pretty quiet on the coronal mass ejection front. So only 71 frames there. Here are some more. Let's just move into the full size. There we are. And yeah, things quite quiet. Let me bring that back. Hardly any activity there. And certainly nothing earthly directed. So let's get the filaments. Here's a great view of filaments from SDO. That's 193 angstrom, 60-minute running difference, along with 304 angstroms. Again, quite a few filaments that are worthy of names. Here they are from Cerro Tololo, Chile. A prominence both in the southeast and the northeast, as well as several dense filaments that are not hanging off the edge of the disk. So let's take a quick count here. So we've got 1, 2, 3, 4, 5, 6, 7, 8. I'll say 10. It's a pretty decent number of filaments, folks. 10 filaments on the Earth-facing portion of the solar disk means high likelihood of solar flares. Not solar flares, high likelihood of coronal mass ejections between now and tomorrow's video. So lots of filaments currently visible on the disk. And before we get to bonus features, there's also a crown prominence up there at the North Polar region. There you can see that C8.8 class flare down here in the southwest. Right in there. There's that C8.8 class flare. There's the full disk view. And here we go. It's time for bonus feature. Satellite charging hazards are first. We ain't got none. It's smooth sailing for satellites. No low-energy electrons building up on spacecraft. No high-energy electrons building up in spacecraft. Here is the layer. Here's the F-layer's electron content, the GOES electron flux, measuring electrons in one slice of the atmosphere using radiography from their geosynchronous near-equatorial orbits by the GOES 16 and GOES 18. There is the one-year graph to contextualize the electron flux. And there's the forecast. Just a mild uptick coming, according to NOAA. I tend to agree. Maybe a little bit more of a significant uptick there, but yeah, mild uptick at least. I suspect it'll be a little bit more of a significant uptick. Next, we'll show the layer where it's measured. The F layer, like I talked about earlier. It is located at about 300 kilometers of altitude. Here it is, courtesy of Australian Government Bureau of Meteorology. And FYI, things are geomagnetically calm, so you're not going to see a lot of major anomalies in the ionosonde. The ionosonde. Here is the anomalygram. That's anomaly in megahertz from the 30-day median. And things continue to look totally normal in the ionosphere. Really no surprises at all. Next, the whole atmosphere model. Total electron content and anomaly on the left, maximum usable radio frequency and anomaly on the right. It's the global ionosphere nowcast. And I'm never gonna wait again for this thing to play all the way through. So I'm going to go to the next tab and close out space weather with the latest high-res images. So quite a bit of magnetism in this area. I'll briefly show that. There we go. Come on then. There we go. Very nice. That was not synced at all. Let me try that again, folks. That's better. So we do see quite a few deltas in this area, especially in this sunspot. This one also up here is quite magnetically complex, Magnetic complexity over here and a little bit down here. So likelihood of large solar flares remains in those groups. And we're going to close out the video in general with meteorology. We're starting things out with the world's highest seas. Yeah, the highest seas in the world are located just north of Newfoundland, where we've got some 33.8 foot waves. That's pretty decent. Again, that's actually the world's stormiest seas. And it's showing surface wind speed animation, and the shading is significant wave height. So yeah, stormiest seas are right there, just north of Newfoundland. Anyway, here are surface winds of the eastern world. Here are the jet streams. Jet streams of the central world and the surface winds. Surface winds of the western world and the jet streams. Clouds and fog for the western world. Shout out to our viewers from the Americas and beyond. If you're viewing the video from a different plane of existence, universe, solar system, spaceship, star system, etc., let us know in the comments. So we have another low that's moving across the country and some blizzard warnings kicking up once again. By the time it gets to the mid-Atlantic states where we are, it's going to turn back to rain. However, at the moment, mixing in with some cold air is that moisture, and it's creating additional snows across the central U.S. So this low pressure here over the southern Rockies and really the U.S. Rockies in general will be making its way to the east-northeast. And that is what's bringing the precipitation. So there's your mean sea level pressure map from windy.com. And here's our weather.gov map. And here's me clicking on stuff that I definitely didn't want to click on. Look at the weather warnings. We got flood warnings. We got all kinds of winter stuff. There is the key. If your location is lit, just head to weather.gov, the homepage of the National Weather Service, and get your weather alerts. I think that might be too many counties for us to cover. But here come some forecasts for you. Starting with the 72-hour pressure and precipitation. You can see that low. It's going to make its way up toward the Great Lakes, but it's going to bring with it a lot of moisture. It's going to bring some heavy storms to the southeastern U.S. And like I said, additional precipitation, heavy precipitation, to the mid-Atlantic states and portions of New England. Also, heavy snows coming to the Pacific Northwest. Shout out to our viewers from Washington and Oregon. You're going to get inundated with heavy rains and snows. Next, accumulated positive snow depth change in inches. 72-hour GFS forecast once again. All the hot air in Colorado is not going to stop it from getting mostly coated with the white stuff in the coming 72 hours. Anyway, I'm not going to try to explain the map. That's why we show it. We'll also show total accumulated precipitation forecast in inches on the GFS 72-hour model. And like I said yesterday, heavy rains coming to large portions of Mississippi, Alabama, Georgia, South Carolina, North Carolina especially. Also Virginia, Pennsylvania, New Jersey, parts of New England, and New York will get inundated, along with the Pacific Northwest, which is expecting some areas with 6 inches of rain. So heavy precipitation here coming to both ends of the country in the next 3 days. Don't say we didn't warn you. There's the forecast. Last but not least, temperature anomaly forecast in degrees Celsius. All the snow that fell in the mid-Atlantic states is going to largely be gone within about 2 or 3 days. So very warm temperatures coming up the East Coast. We'll take it. Cold temperatures will remain west of the Mississippi for the most part. 72-hour temperature anomaly forecast in degrees Celsius, GFS model. Tropical Tidbits is where we get the forecast from. Tropical Tidbits, shout out to Tropical Tidbits. Levi Cohen. What a fantastic website. Now we're showing the cloud thickness is what this is. It's cloud thickness. Yeah, cloud geometric thickness is what that is. I just figured I'd show some different graphic here. We'll also show lightning, courtesy of lightningmaps.org, powered by blitzortung.org. Or if you're Bavarian, blitzortung.org. Shut up, Smash staff, you can't speak German. Lightningmaps.org. Next time you hear thunder, highly recommend it. You could convince the natives that you're Zeus or Thor or something. You could even forecast thunder like a horror movie villain. Anyway, we'll close out with U.S. Doppler radar. Also clouds and fog and water vapor for the lower 48. So there's Doppler, that's vertical motion in the air column from ground-based Doppler radar systems. Here are space-based shortwave radiation satellite images, 3.9 micrometer infrared radiation, and here is the 6.61 micrometer infrared radiation, the water vapor map. When your Doppler is in doubt, use the water vapor map. And if you understand things like this air right here is drier and hence more massive than other similar temperature air, you'll realize that it acts like a blocking feature. You can see this moisture is coming up here and having to make a right because it's colliding with that dry massive air, which is, again, acting like a barrier. Anyway, here's your recap. U.S. Doppler radar map is first. Boston, it's about to clear up. Clouds and fog is next. Water vapor is last. And back to the bunker I go, aghast of all of the spooky things that I've just covered. Oh my God, folks, nature! I'm so spooked of it that I've got to get back to the bunker ASAP, where I can hide and dip things in tomato soup. Anyway, we'll see you soon. In the meantime, may that solar wind be at your back. While I go back to the bunker again, I'm eating MREs so that they don't spoil in 20 years.